Okay, this is class number 3 for grade 12 math. And we'll get right down to business. Lesson 3 in your package, page 35. The weighted mean. In this lesson you will calculate the weighted mean of a data set, learn why some data in a set are given different weightings. So let's first of all give you a definition of what the weighted mean is. Weighted mean defined as follows. Each data value has a weight assigned to it. When calculating the mean or the average. Some data contributes more, some data contributes less. So just for an example, in pretty much any high school course, let's say you're getting some marks for participation. Well, those marks would have a low weight. They're not going to have an enormous impact on your overall mark for the course. Not as much of an impact as the assignments, not as much of an impact as the tests. And if you have a final exam, that might have the highest weight, that might impact your mark the most. Depends what your teacher does. So that's just one example of where the weighted mean is used. So you put more emphasis on certain things and less on others when you're figuring out an average instead of just straight figuring it out. All right, let's go to page 36. And we're going to look at our first example of what weighted mean is. Suppose you have the option of taking one of the following 2 science classes. In one science class, the teacher tells you that the final exam is worth 75%. Assignments are worth 5% and one test is worth 20%. So you've got a lot resting on the final exam in this course. In the second course, now with a different teacher, final exam 33.4%, assignments 33.3%, and 3 tests that are worth a total of 33.3. I'll give you an example. If you're in grade 12 and you're writing the provincial exam for math or ELA, that exam counts for 30% of your course mark. So that has a weighting of 30%, which is a fairly high weighting. It's high enough where if you were to have a low mark in the course and you do poorly on the exam, you might not pass the course. Of course, there are no provincial exams this year, so we don't have to worry about that. But most years, we do. All right. So let's look at an example where we're going to be calculating the weighted mean, but we're going to first talk about the steps to calculating it. You don't need to write these down because you'll find them very nicely laid out on page 37. This is the formula for the weighted mean. It's not complicated at all in the slightest. I'm not even going to refer to it all that much. We're going to go here instead. Steps to find the weighted mean. Multiply each individual data by its weight. So for example, in the example we just looked at, assignments are worth 5%. So you would take the average mark of all the assignments and multiply them by 0.05. You would take the mark of the one test and multiply it by 0.20, and you would take the mark of the final exam and multiply it by 0.75. Multiply each individual data value by its weight. And we'll do an example in a second. Add the answers you found in step 1. This answer is the numerator of the weighted mean formula. So that's the top part of the fraction. Add the weights of each type of mean. So in the example from the science class, the weights of each type were 75, 5, and 20. We add those together out of 100. And then we divide top by bottom, and you get your weighted mean. So we're going to take a look at this example here and work our way through it. You want to determine your final mark in grade 12 essential mathematics. Assignments are worth 75%, a midterm is worth 12.5, and the final exam is worth 12.5. First of all, this is impossible. If you're writing a provincial exam, it's worth 30. But that's okay, we'll do the example anyways. Hey, maybe this was written for COVID-19, who knows. You have received a mean mark of 76 on all your assignments. You also received a mark of 68 on your midterm exam, and you estimate you can get 80% on your final. So what will be your final mark? Well, let's do the work on this. Assignments are worth 75%, and you have an average mark of 76 on your assignments. 76 times 0.75. Calculate for that one. 57. You had a mark of 68 on your midterm exam, and that's worth 12.5%, 0.25, 8.5. And you expect to get an 80 on your final. So this person is optimistic, thinking they can do very well on the very last assignment of the course. I wouldn't let it get to that point personally, but hey. 10. 80 times 0.25 is 10. Add up these three numbers. 57, add 8.5, add 10. And then you add up the three weighting numbers. 75 at 12.5, at 12.5, 57 at 8.5, add 10, 75.5. These guys add up to 100. So basically now you just divide, and of course it's going to be 75.5% because you're just dividing by 100. 75.5 divide by 100, you get 0.755, which is 75.5%. That's your mark in that science course, based on the weighting system, the way it's set up. Let's now go to an example of an English class. This is example number 2. read that one. This is page 39, example number 2. The teachers of 2 grade 12 English classes at Vincent Massey High School want to find the mean final exam score for both classes. The first class has 24 students and its mean final exam is 62. Second class has 30 students, so its mean final exam is 78. What is the mean final exam score of both classes? Well, you don't just want to take the average here because this class has more students. So you want to weight this class a little more heavily than the first one. Okay? So there's more students here. If you just take the you don't just want to do 62 at 78 divided by 2. That does not give you an accurate reflection of what happened because the group that got 78 is bigger. Like if I just do 62 add 78 divide by 2, I get 70%. But the average is higher than 70% because the group, this is a bigger group. So we take that into account by doing the weighted mean. Should have labeled the previous example. We didn't. I didn't. Example 2, the English class. Page 39. The class that has a 62% average had 24 students. So we go 62, your weighting is then 24. 78% had 30 students. Your weighting is then 30. And now we're going to multiply. 62 times 24 is 1488. And 78 times 30 is 2,340. Now we add those two together. 1488, 2340, divide by the two weights, 24 and 30. Let's get the totals here. 38, 28, divide by 24 at 30 is 54. And just my final step, divide by 54. 70.88 or 71%. So when you do a weighted mean, you get a mark that better reflects. As I said, if you just added the two averages up, divide by 2, you would have got 70%. Here we get 70.88, 70.9, or almost 71%. So you get a more accurate reflection of what the average mark actually was between the two groups, accounting for the difference in group size. Just another example of where you would use the weighted mean. Now we're going to flip over to page 43 and take a look at some brain power. And then we'll do a few other examples. A couple other examples and we'll leave you with a bit of homework to do. What is the lowest common multiple of 6 and 8? Evaluate 3 to the power of 4. How many millimeters are there in 14.1 meters? In a standard deck of 52 cards, what is the probability that you will draw a red card? And then evaluate 1/2, take away 9, 30 seconds. Okay. So I should have enough space on the sheet, I would think. Brain power, page 43. Number 1. Lowest common multiple. LCM of 6 and 8. So you simply list their times tables until you find the one that they have in common. 6, 12, 18, 24. Let's do 8. 8, 16, 24. We're done. The lowest common multiple is 24. 2. Evaluate 3 to the power of 4. That is 3 times 3 times 3 multiplied 4 times. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3, if my mental math is correct, is 81. And I'm pretty sure that's correct. 27 times 3, 3 20s, 3 7s. Yep, it is. You get 60 at 21, that's 81. How many millimeters in 14.1 meters? 14.1 meters. You gotta know how many millimeters are in a meter. There's 1,000. So the decimal jumps over a couple of places and you get 14,100 millimeters because it moves. Once over and then 2 more zeros. 14,100 millimeters. In the standard deck, what's the probability that you will draw a red card? Well, half the cards are red, right? 26 out of 52, 1/2. 1/2, take away 9/37 for number 5. Let's do that one over here. 1/2, take away 9/32. Well, we need a common denominator, so we'll change this one to a 32. We'll increase this. So 2 times what equals 32? Which number do I have to double to get a 32? 16. 2 times 16. So that's 32. And 1 times 16 is 16. So 16 over 32 minus 9. 16 minus 9 is 6, 7. 7/32. And that, of course, is 5. Okay, that's your brain power. Again, there'll be a brain power test at the end of the course. Have a look at some of the homework. We're going to do a few examples and leave, as I said, and leave you with the rest for homework. So you'll find all of this on page 44 to 45. Don't worry about any of the 44 to 46. We're going to look at number 1 on page 44. We're going to do that one first. So let's take a look. This is page 44, number 1. One high school psychology class. The marks are weighted as follows. Test 1, 15%. Test 2, 25%. Test 3, 10%. Assignments, 20. Participation, 5. Final exam, 25. So you're comparing marks for 2 different people here. So he got on the 3 tests, 80, 73, and 69. 83 on assignments, 100 for participation, 65 on the final exam. So we're going to evaluate these 2 people separately in terms of how they did in the course, Jeannie and Scotty. So this is weighted mean, page 44, number 1. So we'll do Janie first. She got 80 on the first test. 80 times 0.15. She got a 73. 0.25. And she got a 69, which was 0.10. And for assignments, she had an 83 average. 20. She had 100 in participation. It's 0.05. And 65 on the final exam. And that would be 0.25. Now let's set him up. Scott. He got a 79. It's 0.15. And an 84. It's 0.25. And he got a 73 times 0.10, and he got a 52 times 0.20, and he got a 97 times 0.05, and an 87 on the final exam, which was worth 25%. So we'll work through her calculations first. 80 times 0.15 and so on. 12. 18.25. 6.9. This will be 5. Don't need to calculate that one. 65 times 0.25 is 16.25. 79 times 0.15. Now we're doing Scott's calculations. 11.85. 4. 21. This will be 7.3 times 0.2. 4.85. Participation. 21.7. All right. Let's just check that the weightings add up to 100. 40, 50, 60, 70, 75, 25. Yeah. They're out of 100. So we need her total out of 100. 12 times 18.25, 6.9, 16.65, and 75. So he has got, or she has got, 75% in the course, and he has got, let's get the total here. 77.15 out of 100, so basically 77%. So even though he appeared to not be doing as well, in fact he only got a 52 on his assignments, because he did so much better on the final exam, he ends up with a higher mark. That's one of the advantages of the weighted mean. You might know the saying, it's not how you start, it's how you finish. Well, the weighted mean, one advantage of it, it allows you to put more emphasis on your finish. And then you might get your overall result to be better. Now, somebody like her doesn't really benefit from the weighted mean. Somebody who kind of is pretty consistent all throughout, but maybe had and was a good student, but maybe had a bad day on the final test, and because of that heavy weighting, it cost her. Or maybe it was just the stress of the test. Who knows? But that's the other question there, is why is his higher? It's because he got such a good mark on the exam, much better than hers, and the exam was weighted very heavily, heavier than anything else in the entire course. Oh, well, actually, no. The first test was also 25, but he also got a very good mark. He got his best marks on the 2 assignments that were worth the most, other than participation, of course, in 84 and in 87. That was half the course right there, 0.25 and 0.25, 0.50. That was half the course. She got a 65 and a 73. Those are 65 isn't great, 73 is average. So he did better because he did well on the things that were weighted the most. So the weighted mean worked in his favor clearly. Let's do number 5 on page 46. I'll take a look at that one. Number 5 on page 46. Celine just received her marks for her first year in university. Celine now wants to know what her grade point average, GPA, or weighted mean is. And she received the following marks, and when you get those marks, this is then your grade point average. An A is a 4, a B is a 3, a C is a 2, and a D is a 1. And she had 1 half-year course, which means the weighting will be divided by 2. So we're going to calculate her average mark. So in history, she gets a C. The C is a 2. In calculus, she gets a B. It's a 3. Enter to English, she gets an A. That's a 4. Chemistry, she gets a B. It's a 3. Physics, she gets a C. That's a 2. She got an A in Spanish, but Spanish, it said, was a half credit. So that means she gets 2 points for it. She got an A, which is a 4, but it's a half credit, so she gets 2 points for it. 5, 9, 12, 13, 14, 15, 16. So she got, her total is 16. We're going to divide this by her total points, which is 6. The number of data points, 16 divided by 6. She has a grade point average of 2.66. So her average is pretty close to a B. 2.66, pretty close to a B average. Okay, simple as that was a fairly straightforward example. Let's look at the ones you'll be doing on your own. We're going to circle them as we go. So, first one, it's going to be number 2. Residents from 2 towns in Manitoba were asked for their IQ scores. 250 people from A town reported their IQ scores, and the mean IQ score was 120. Smart people. 100 people from B town reported their IQ scores, and the mean score was 90. What is the mean IQ of all residents in both towns? Now you want to do a weighting here. The town with a 120 IQ score has 250 people, and the one with a 90 has 100 people. So you want to weight that. It's similar to example, which example was that? The English class example. It's similar to the English class example, this question. Okay, that's number 2. Got a circle around that one. And also have you try 3 and 4. One retail company wants to determine how long its employees have been working for it. It found the following statistics. 4 people had worked at the company for 1, 8 people had worked for 1 year, 5 for 2, 4 for 3, 7 for 4, 5 for 5. Calculate the mean number of years that employees have worked for this company without using the weighted mean. Okay. So the way you do this, 8 people worked for 1 year. So that's simply 1 year. You simply take all the years and add them up, right? So 1, add 2, add 3, add 4, add 5. That's how you do it without the weighted mean, okay? Just add up the 5 numbers and divide by 5. That's how you do it without the weighted mean. If you're doing it with the weighted mean, you got to do 8 times 1, so that's 8, then 5 times 2, there's 10. You got to get the total number of years, and then 12, and then 28, 7 times 4, and 5 times 5 is 25. You get the total number of years and the total number, and then you take the total number of people. You got your years, you take your people, add them all up, and you're going to divide the 2. Okay. I'm thinking, let's do this one together, and then I'll leave you guys with 2 and 4. So let me grab this sheet. So this first one, without the weighting, is pretty simple. So this is page 45, number 3. So we're just going to take the average. 1, add 2, add 3. Add 4, add 5, 9, 12, 14, 15. Divide that by 5. And it seems like everybody has worked for this company for an average of 5 years, if you just do it that way. But now we do 8 times 1 is 8. 5 times 2 is 10. 4 times 3 is 12. 7 times 4 is 28. 5 times 5 is 25. So we add this up, 8, 10, 12, 28, and 25. That's an 83. And we want to add up the number of people. So we'll simply do it here. 8, 5, 4, 7, 5, 13, 17, 24, 29. And what do we do then? 83 divided by 29. 2.86. Or 2.9 years. This is a much better reflection of how long people have been working for this company. A 5-year average versus a 2.9-year average when we use the weighted mean. We actually work everything out separately, so we take into account how many have been 1 year, how many were 5 years, how many were 3 years, and so on. Take all that into account, your weighted mean, and it becomes 2.9 years. Honestly, in this particular case, the only mean that even makes sense to use is the weighted mean. The other number doesn't even really make any sense. Okay, so we'll wrap it up. Your homework will be pages 44 to 45, 2 and 4. Number 4 is pretty self-explanatory. I'll just leave you with that one. 2 and 4. If you have any questions, you can post them in the comment box or drop an email. Right? We will wrap it up there.